Welcome to solverfy.
So now we'll work on problem 96 from chapter 17. In this problem, we're asked how many microliters of 1 molar NaOH solution must be added to 25 milliliters of a 0.1 molar solution of lactic acid to produce a buffer with pH equal to 3.75. So we can go ahead and write the Ka for lactic acid, which is 1.4 times 10 to the minus 4. And since we're dealing with a buffer here, we put in a Henderson-Hasselbalch equation. And the pKa will be equal to 3.75, and then we have the log of base over acid. So we subtract 3.75 from both sides and take the anti-log to get the base over acid ratio equal to 0.794. And we can also say that the reaction that we'll use is based on the beginning concentration of the acid. Both species, the base and the acid, have to be equal to the same concentration which we're given at the beginning. Because we're not producing new base, we're just converting the acid to the base. So from our first equation, we can say that the base is equal to 0.794 times the acid, which means that if we combine to this reaction, 0.794 acid plus acid would be 1.794 acid equal to 0.1000 molar. So concentration of acid is equal to 0.0557 molar. And if we simply subtract this value from 0.1, we plug in our value here and solve for the base, we get 0.0443 molar. So that's our concentration of the lactic acid and lactate in this solution. So now we need to figure out how much volume of NaOH is needed to do this. So we need this amount of moles. So we have 0.0443 molarity times 0.025 liters is equal to, we need 1.11 times 10 to the minus 3 moles. So we have 1.11 times 10 to the minus 3 moles, and we divide by the concentration of hydroxide, which is 1.00 molar, and we get a value equal to 1.11 times 10 to the minus 3 liters. And if we convert to microliters, because the question specifically asks for that, it's 1,110 microliters.